Set theory is probably the one that I get the most questions about in this course. If I'm looking at sets, they have their own language. And so we're really just going to break apart what is the language and notation. And if we understand the language and notation, that's going to be half the battle with this section. So what I'm calling a set is really just a group of objects. So if I take all of the change in my wallet and I put all the quarters in a pile, all the pennies in a pile, all the nickels in one pile, those are sets. I have collected like objects into groups. That's what a set is. And so an element would be 1/4 from that set, or 1 nickel. That would be an element because it's one item that is a part of those groupings that I created with the change. And so if I want to start using set notation, it's wonderful. It's basically shorthand. So the set title, C, the abbreviation, goes in front of the equal sign. If I was trying to do my set of coins, C would make sense for coins. You pick that letter if it's not given, and then you would say C equals, and the brackets mean the set, the variable of all X, such that X is a carnivorous animal. So I find out C actually stands for carnivore, and that my variable is a carnivorous animal. Maybe a carnivorous animal. Think of those. Maybe it's a lion. That's a carnivorous animal. That could be one of my elements in my set. And so I'm basically trying to describe the group by their characteristic. So the characteristic of this animal group is that they are carnivores. And that's how I've chosen to set them up. A set is well defined anytime I can tell what the grouping is. So if I have a group of quarters, that would be well defined because it would be quarters. If I had a set of quarters, nickels, and dimes, that wouldn't be a well-defined set because I'd be trying to figure out what's the grouping here. And it might be that they're all silver, but that seems rather broad because then there's other silver coins that aren't included. So a well-defined set is when you're able to pick up on what characteristic is grouping them. So if I say that X is the set of where X is a winner of an Academy Award, that's pretty easy, right? Academy Awards, we have a list every year. You know who won it, you know who didn't. That's a well-defined set. But what about T equals X such that X is tall? Well, what is tall? Because I'm from South Louisiana, and if you're over 5'3", you are tall here. But if you're somewhere else, you might be really short at 5'3". So there's a kind of ambiguous feel there because in the Academy Award group, it's really easy to look it up. But in the tall group, I don't really know who is tall. Like, what's your frame of reference? Are you 6 foot? So people who are tall are taller than you? So you've got to be specific. Specificity is the key here. Now, I have some interesting definitions here, such as the empty set or null set. That means there's nothing inside of it. It's just empty. It's just empty. So the set of all nothing is nothing. And that might seem like it really doesn't make any sense, but does the set of nothing have the same meaning as nothing or empty? And does the empty set and 0 mean the same thing? No, those do not mean the same thing in part A. To be more clear, you might think of a set as a paper bag that you would get as a supermarket, and then the empty set would be an empty bag. Whereas the set actually has an item in it. It has a bag, but the bag is empty. So that's kind of the contradictory statement for the counterexample. If I have an empty paper bag, I have something in my set. I have something there. Even though there's nothing inside of it, there's still an item there. And then for part B, it's similarly the same idea. So if I were to pose that from the opposite end of things, just because you have something is empty doesn't mean that there's nothing in the set either. And so how do we represent sets? So the universal set would be everything. So if I'm talking about sports in a high school, the universal set would be every possible thing that could be considered a sport in the high school. And I would use that always to be the letter U. So you never want to group a set and call it U, because that is always the universal set. So if I look at the bottom, the universal set equals X such that X is a female consumer living in the US. So that means my variable stands for female consumers that live in the US. Now I have two other symbols. So the little E means is an element of. Remember, an element of a set is an item inside of it. And an E with a strike through means it is not an element of my set. So if I look at this, let's replace the pound with either an element or not an element. So in part A, is 3 a part of the set? Yes. So it would have the element. In B, is 5 a part of that set? Yes. So it's going to have an element. Is Bill Gates a billionaire? Pretty sure he is, so that's going to be an element. Is jogging an aerobic exercise? Probably, maybe. And then, is the Ace of Hearts a face card? And so what do we know? The set of 5 is not an element of this set because this set is just numbers. And then the final one, an ace, is not a face card. So that can be a little bit tricky if you're not playing cards on a regular basis. Now, a cardinal number is much easier than it sounds. It's the number of items in the set. You just count them up. And if a set has no end, then it's infinite. And so the cardinal number represents the number of items there, and it's always going to be a whole number. So this, I think of this as the number of items in A. And so if I say, X such that X is a planet in our solar system, well, there's 8 planets. So the cardinal number N of planets is 8. And this set, it has ... which means it keeps going forever. So it doesn't have an end. It's an infinite set. In part C, this is tricky because there's a lot of people living in the U.S. that aren't citizens, but it's not an infinite number. It's a very finite number if I look at it. So it's going to be a very large number. If I look at the empty set has a 0 cardinality because there are 0 items in the empty set. And if I look at this set, I have 3 subsets. Therefore, the number of items in E is actually 3 because it rolls by subsets.